What is the value of ratio of self-inductance of a given two solenoid A and B? Whereas the value of permeability and area of cross-section of two given solenoids are same. But the length of A is twice that of B and the number of turns per unit length in A is half that of B. So here, if we are taking the length of solenoid B as L, then we can say the length of solenoid A will be equal to 2L. Similarly, I'm going to take N as a number of turns in the solenoid B. We can write number of turns in A as N over 2. It's known that the self-inductance can be calculated using a formula mu n square A divided by L. So here we can write the equation for both. So LA will be equal to mu n A square A divided by LA because mu and A remain same for both. So LB can be written as mu n B square times A divided by LB. It's known that NA or NB, N in the general formula is representing number of turns per unit length. So here number of turns in the solenoid A can be written as N over 2 times 2L because it is N over 2 number of turns and the length 2L. So it will be NL. Similarly, NB can be written as number of turns N and the length NL. So it will be NL. So let us calculate the value of LA divided by LB. So which will be equal to mu NA square A divided by LA divided by mu NB squared A divided by N. When we are simplifying the terms, we will get NA squared divided by LA divided by NB squared divided by LB. So here we calculated the value of NA. NA is also same, so we can cancel each other and we can write this will be equal to LB divided by LA. So whereas LB is the length of a solenoid B which is given as L, whereas length of a solenoid A is 2L. So if we are applying the values, LA self-inductance ratio will be equal to 1 over 2. So here we can write this as 1 is to 2. So the correct answer for the question is option A here.